Okay, hello Ledesma. The math guy is back. We're going to talk a little more about quadrilaterals in our second video today. So I want you to take a look right here. Remember that a quadrilateral is any four-sided shape, and it's a quadrilateral, right? So you have all these different examples of quadrilaterals, four-sided polygons. So what we're going to talk about today is the angles in a quadrilateral. But to do that, we're going to review the angles in a triangle. So take a look right here, right? The sum of the angles in a triangle is 180 degrees, and that was from a previous lesson from earlier this year. But if you take a look at it, this is your standard equilateral triangle. It has 60 degrees plus 60 degrees plus 60 degrees. Add all those up, you get 180 degrees is the sum of the interior angles in a triangle. And all triangles add up to 180 degrees. But if you put two triangles together, take a look at what happens. You get a quadrilateral, right? So if you have two triangles put together, you get a quadrilateral. And 180 plus 180 is 360 degrees. So that brings us to our next point, which is that the sum of the angles in a quadrilateral is 360 degrees. And take a look, this is your standard rectangle here, right? And you can see each corner is 90 degrees, 90 plus 90 plus 90 plus 90, or 90 times 4 is 360. And take a look at what I just said about the other day. If you take and cut this rectangle in half, you would get two triangles. And that would be each 180 degrees in each of those triangles. So the sum of the angles of the interior angles in a quadrilateral is 360 degrees. Take a look down here. We have a trapezoid, right? Again, 60 degrees plus 60 degrees, 120 and 120. If you put all of those interior angles together, you get 360 degrees. So that's how quadrilaterals work. The sum of the interior angles, 360. I'm going to give you an example problem right now. This example problem is for an irregular quadrilateral, right? So this is not any specific type of quadrilateral, just an irregular one. But take a look at the degrees on the interior angles. 70 for this one, 110 degrees for this one, 120 degrees here, and some unknown measurement here. Well, we do know that if you put them all together, 70 plus 110 plus 120 plus whatever x is, you will have to get 360 degrees. So let's think about how we will do that. How are we going to solve for that value of x? So you're going to take it and you are going to add these together. So you're going to say 70 plus 110 plus 120, and you're going to add them all up. You get a 0 here. 7 plus 1 plus 2, that is 10, carry the 1, and you get 300 degrees. So now we can take 360, okay, so we can take 360 minus 300, and you will get 60 degrees left over. So take a look at what I did there, right? We added up all those angles, 70, 110, and 120, we got 300. And then we subtracted that 300 from 360, and we got 60 degrees total for our quadrilateral, for our last missing angle in our quadrilateral. So x will equal 60 degrees on this particular quadrilateral. Hopefully that makes sense. I will give you one more example of a quadrilateral to figure out here. This time I'm going to give you a parallelogram. All right, and this parallelogram is going to have one angle that you know, and you have to figure out all of the other angles. Okay, so the one known angle is going to be 50 degrees on this parallelogram. Okay, now on parallelograms, opposite sides are equal. So you know that angle A right here has to be congruent with the 50 degrees. So angle A is the first one, the most obvious one that you will know on this parallelogram, but we still don't know what angles B and C are. So angles B and C, well, we know that angle A is 50 and its opposite angle is also 50, so that's 100 degrees. We can take that away from 360, so we say 360 minus 100, and we get 260 left. And so we know the last two angles have to equal 260 degrees. B and C have to be congruent because this is a parallelogram. Okay, so we can take that 260 and divide it by 2. So if I did 260 divided by 2, I would get 130 degrees each. Now I don't expect you to have to do that in your head. I don't have room on this little whiteboard to do that, but you can go ahead and write that out as long division if you need some help with that. But so now you know that angle A is 50 degrees because it's congruent with its opposite angle in a parallelogram. And then B and C, you have to simply take away that 100 degrees, you get 260, and you divide that by 2 because those two have to be equivalent as well. So B and C are going to be 130 degrees each. And that is how you solve for unknown angles in a quadrilateral. Keep working on it, keep studying, and I would encourage all of you to ask questions. Thanks, and I hope you have a great day.